In this lesson, we'll take a look at some of the basic operations we can do. So let's create a new Java application. We'll call it Basic Ops. This will mostly be the math operations that we can do in Java. And it helps if you can see what Java's doing. So we're going to print out the results of these things. So of course there's the typical operators like 3 times 5. The star is multiplication in Java. So if I run that, Java will spit out 15 as my program. There's also plus and minus. And as well there's division. But division's kind of funny because 3 divided by 5, so you might think of that as 0.6. Actually comes out to be 0 in Java, and that's on purpose because the data types we're working with here are integers. And when you have two integers, it gives you an integer back. And since there's no integer for 0.6, it just throws the decimal away. So for example, if it's something like 8 out of 5, that's 1.6. If I run it, it's going to throw away the 0.6 and I end up with just 1. So how do you correct that then if you want to keep the decimal around? Well, you just need to make one of these into a decimal number. Now that Java sees a decimal, it puts it there. So as long as either one or both have a decimal, Java will keep that around for you. So in Java, we refer to these things a little differently. An int is an integer. So you're going to hear that terminology. We're going to learn about declaring these a little later. And a double is the term we use for floating point numbers. So when you hear me say double, what I mean is a decimal or a floating point number. When you hear me say int, I'm talking about integers. Now aside from basic math operations, integers have another neat little feature in it called the modulus. And modulus is a fancy math term for remainder. So what happens to that the extra bit that was thrown away? We can recover it. So when we said 8 divided by 5 and it threw away the remainder, all you had was the whole number. Well, if you want to get the remainder back, you use this little percent sign, and that percent means mod or remainder. So 8 mod 5, that's going to be 1, and the remainder is 3 out of 5. So if you remember this kind of division from elementary school, 8 divided by 5 is 1, remainder 3. And if I run it, that 8 mod 5 is going to spit out 3 now. So the remainder. Right, we can try another one here, like 27 mod 5. That's 5, remainder 2. So when I spit this out, I now have 2 as the remainder. Okay. So we can even make a program that would look something like this. 27 divided by 5 is, use my plus sign to say here's the whole number part of it with remainder, and here is the remainder. So now when I do it, 27 divided by 5 is 5 with remainder 2. So you can change the numbers around in this, but to illustrate how you get the remainder operator in Java. Now there's a lot more applications for this than you think. We're going to use it a lot, so don't think that because you don't use remainder too much, maybe in your daily life you'll use it a lot in computer science. Now precedence works in Java just like it does in regular mathematics. So let me just peel this off here. So for example, if I went 1 plus 2 times 3, then it's going to do the multiplication first, then the addition. So it's going to end up with 7. Okay, so there's the 7. We can, of course, just like regular math, change the order that it does it. 1 plus 3, so 4 times 2, I should get 8 this time. And there it is. So just like you know from math, you can use the brackets as well as the operators to help you manipulate your mathematical expressions. So we talked about this in the last brief lesson here. If we were to change this around instead of doing divisions, what if we were to talk about the plus sign? So I could do something like 8 plus 3 is, and then go 8 plus 3. Whoops, and I got to join them. So what's going to happen here is I'm going to end up with 83. Oops, I have an error here. Where's my mistake? 8 plus 3, there's a colon instead of a semicolon. Okay, 8 plus 3 is 83, because remember, this is a string. If I join it with anything else, it's going to be just pushed together. So that becomes a string now. Joined with a number becomes another string. So the only way you can avoid that is if you put your mathematics in brackets to separate it so that this will be done before we join it. Okay, so 8 plus 3 is 11. So again, if you're just, it's a careless mistake, but if you're going to do mathematics, you should probably put it in brackets if you're going to mix it with your text. That way you don't have to worry about that kind of problem happening to you. So just to give you an idea here of where we're going to be headed now, we need to learn to work with a variable. So these things, these ints and doubles we talked about, I'm going to show you how we could declare this as a variable. So I'm going to go int 1 equals 5, and I'll explain what I'm doing here in a second. Now, the reason why this is going to be a lot better for us to work with is when we use the same number, like 8 and 3, they reappear here, 8 and 3. If we keep repeating that number, we don't want to always write the number in, because if I go and change this to a 4, this doesn't automatically get changed either. So no matter where it is all throughout, I got to go find it and change it manually, and that's not very efficient. So the way I'm going to rewrite this is I'm going to use variables instead. And the way you declare it to Java is you tell it what type the variable is. And in this case, 5 is an integer. So int, what's the name going to be? This variable's name is 1, and its value is 5. So this means that Java is going to go into your computer's memory, it's going to get some space in the memory, and it's going to put the number 5 in the computer's memory for you. And it'll hang on to it. So whenever you want to refer to it or find it, you can just say, okay, get me the number by referring to it as 1. Okay. So the reason I chose those names, I guess doesn't make the most sense to call 1 equal to 5, is I'm calling this the first number. Yeah, why don't we call it that instead? Java has this neat feature. If you refactor it, then you can rename it. And I'm going to call this first. And you can also do it with Control R. And I'm going to call this second. So that way, when I'm doing my program, the first number plus the second number is, and then here I'll go first plus second. So when I run it now, I'm going to have 5 plus 7 is 12. But the great part about this is if you want to know what's 15 plus 36, I just change it there and everything else in the program is updated for me. So it's much more versatile. So first is this number 15, and it's stored in the computer's memory. When I want to refer to it, I get it here by using the name first. So I'm using the number 15 plus this string is going to appear between them. Then the number 36 is going to be joined to it. Then it's going to be joined with is. Then it's going to be joined with the actual math that puts them together. So just to show you how far you could go with this even, I'm going to make a multiplication table. And I'm going to use it a whole bunch of times. So let's say 1 times 1 plus the tab plus 1 times 2 and 1 times 3, and we'll do one more. And then I'll copy and paste this a bunch of times to help build up this multiplication table. So now I have to find all those 1s and turn them into 2s there, 3s there, 4s there. Go all the way through this multiplication table. Make all those changes and hope I didn't forget something. But when I'm done, I'm going to have this neat little multiplication table that Java's going to spit out for me. So there it is. So like 1 times 3, 3 times 3, 4 times 2, you can find it all on the table there. But that's not very efficient again, because now what if all of a sudden you don't want to work with those numbers anymore, you want to use different ones. So here's what I'm going to do. I'm going to go int start equals 1. So then I'm going to replace this with start. And the next one is going to be start plus 1. So I need to put it in as start plus 1. So we'll put that all the way through as well. And this will be start plus 2. And this one here will be start plus 3. And of course, there are much more efficient ways to do this once we learn some more Java, but for now, this is going to do the same thing we had before, which you might think, who cares then? But I can move that. Now it's going to start at 3 and go down to 6. So there's the 3 times table, 4, 5, 6. One change, and I get a whole new program that spits out here. And I only have to make the change in one place. So that's the way you want to do your programs. The way it was done before, when the numbers all appear everywhere and are repeated, we call those magic numbers in programming, meaning we don't know why they're there and we're not sure. Like, if I change the number 2 in this part of my program, do I have to find every other 2? If you're not sure and you're repeating that number, then you should be using a variable. So that's what I'm going to be looking for in your programs. If the number's repeated, you have to use a variable. If it's only used one time, that's fine. You can just use it one time. But if it's ever repeated or used for anything else, it has to go into a variable or you'll lose points for that. Now, what if we don't want anyone to have a chance of changing this? Like if I put something here, .out.println, and I say a times table starting at 3. And I want to make sure that people aren't going to be able to change my program. Well, one thing you can do in Java to make a constant is you can call it final. So if you go like this and call it final integer start, final tells Java no one else can change it. Now that it's been set, it has to be that way. So if I go here and I try to make start equal 9, I get an error because it's going to say that cannot assign a value to a final variable. So that way at least I know as I go through the rest of my program that it's going to have the same value I expect. And when we use constants, the way we use a convention here is we do them in all capitals, like that. So that's again another style thing I'm going to be looking for in your code. If you look up code on the internet, you're going to see that this is something that most programmers do. 99% of them do this. The other percent probably don't know that it's the etiquette that we use. Because now when I'm looking through someone else's code, I know without having to find it that this has got to be a constant. Otherwise I got to find it up here and go, okay, yeah, this is the constant, and know what I'm doing with it. So whenever you are using a value that should not be changed, I'll be looking for you to use that final int as a constant. So for example, maybe you want to declare something like pi. Okay, so there's, sorry, should be a double because it's a floating point number. There's how I could declare it in Java, and I know now whenever I refer to it later in my program that it's not going to have been changed from what it started as 3.1415. So we're going to have you do a little time program here. So let me just comment this out. I'll just remove it. So the time program that you're going to work on is going to give, someone's going to give you amount of seconds, and you're going to come up with hours, minutes, and seconds. You're going to parse it. So what that would look like, for example, this would be if we just did it without any calculation and we just said, okay, 100 seconds is, that's going to be 1 minute, and let's see here, 40 seconds. Right? Or we could write it like 1 minute, 40 seconds. But what if we wanted to do better than that and we actually wanted to know how to break up this 100 minutes? Well, if you haven't thought about what you do in your head there, 100, what we're doing is we're dividing it by 60 to get the number of minutes. That's 1 whole minute, and the remainder is 40 seconds. So we're going to be using the integer division and integer remainder, and that's what I want you to show me that you understand in this first program. Okay, so you're going to write a program that will take a number, so I'm going to go int time, and your job is to say how many hours, minutes, and seconds it is using mod and div. You can use any more variables that you want, but this is the only thing I want to be able to come to your computer, and I want to be able to change this, and I want to see your program run properly again. So maybe I'll make it different here, and I want to see your program spit out the right number of hours, minutes, and seconds using div and remainder. Okay? For your next exercise, what you're going to do is a conversion. So, for example, I'll show you if I wanted to do int, let's make this a constant, and it's a double. This is going to be inches per centimeter. Let's go inches per foot. They're 12. So I guess I could, after all, just make it an int. And let's just say that you give me double feet equals 10. Then I'm going to print out for you that that many feet is equal to, and I'm going to put my conversion in here, feet times inches per foot. Inches. Okay. So in this case, if I run it, it's going to say 10 feet is 120 inches. Okay. So I want you to do conversion programs for me as well, and the conversion programs that you're going to do are going to be for pounds to kilograms, miles to kilometers, and I'd also like to see you do a Celsius to Fahrenheit conversion. So you give me the degrees in Celsius, and I'll tell you how much Fahrenheit it is. So your program should be able to make that conversion for me. Now remember, when you're doing this, like me, you should use constants where you don't want the value to change. And I want to see variables used in your program. See, feet reappears a bunch of times, so it should have a variable. And finally, the last thing I'm going to want you to do is you can pick 3 geometric formulas you want. So they could be things like surface area, volume, whatever you want. And I want you to come up with a program. So for example, let's just say, and we'll say you can't do this one, volume of a cube. That's just going to be x cubed, right? So let's go double the length equals 5, and I'm going to spit out what the volume of that cube would be. So it'll be 125. Now, when you do this, one of them has to use pi, and you need to declare it as a constant. Okay? So I don't care what you do for the other two, but I want to see you using variables and giving me a program that will do the volume or surface area, whatever you like, for 3 formulas, and one has to include pi, so I can see you practicing using your constants. Remember, they should be capitalized when you use a constant.